right, pick up your colored pens. Today's special warm-up is an activity that actually encompasses everything you learned in Chapter 1. This one simple activity encompasses everything. The activity is to find the treasure, the hidden treasure. So we are actually going to start with question number 4, which is, where is the treasure? So let's see who found it. We'll start with Najee, Aaron, Amaya. Where's the treasure? Okay? Okay?
-6, -4.
So we have 3 different people think 3 different locations of the treasure. I wonder if any of them actually found it. Christian, and then Ethan, and then Yasmin.
-2,
Okay?
-2, -4.
Is that what you said, Najee? So we have 2 people who agree. I wonder if they'll be fighting over the treasure in a couple of minutes. Yasmin? Okay, that's a different location. Nicole, what'd you get?
-2,
-2, 1. I don't think anyone said that. Benjamin, where's the treasure? Okay. Well, in my classroom, you got to work through. You had a lot of time to do this. Brianna, where did you find the treasure? Well, the treasure is at -2, +4. So now let's go back and mark each of them, because a lot of us got question number 1 correct and then you couldn't do anything after that. That's a huge problem. Because I said that this activity encompasses everything from last chapter, and if you can't do numbers 2, 3, and 4, then you did not learn what you were supposed to learn in the last chapter. Let's start with number 1. After we do this clue, add 1 to the x-coordinate and 2 to the y-coordinate, where are we? Deandra? 4, 4. That is right. So let me back up for a second and let me do it on the graph so that we can see the movement on the graph as well. This is the starting point. This location is 3, 2. I was a little disappointed that nobody wrote that down, or a few people did, but this is the starting point. How could you not write that down if you need to add things to it and do things to it? You need that piece of information. Okay, so you made a mistake, but some people were still able to get number 1 correct. So it says add 1 to the x-coordinate, +1. Add 2 to the y-coordinate, +2. 3 + 1 is 4. 2 + 2 is 4. Any questions about how we got the location after clue number 1? So now we are at 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now we are here after clue number 1. Now clue number 2 says divide both the x and y coordinate by -2. So what it's saying is do this. So what's 4 divided by 2? Could someone raise their hand and tell us what's 4 divided by 2? Forget about that. Just what's 4 divided by 2? Justin? I'm sorry? 2. Okay, so what's the rules that you learned in my classroom when you're dividing positives and negatives? What are those rules that you're supposed to have in your brain, India? Very good. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. And so when we divide by both the x and y by -2, we end up at -2, -2. So the next location is -2, -2 right here. Again, you didn't have to graph it because you don't need the graph. You need the numbers. So this is where we're at after clue number 2. Then clue number 3 says add 3 to the x-coordinate, +3. And add -2 to the y-coordinate, +2. So what's -2 + plus 3 and negative 2 plus negative 2. Where are we going to end up now? Brianna?
1, negative 4.
Very good. 1 comma negative 4. Negative 2 plus 3 is 1. Negative 2 plus negative 2 is negative 4. So now we are at 1, negative 4. 1, 2, 3, 4. Now we are here after clue number 3. And then it says multiply the x coordinate by negative 2. So it says times negative 2. And the y coordinate times negative 1. So times negative 1. India, what were those rules again that you told us?
If the signs are the same, it's positive, and if the signs are different, it's negative.
Very good. We're talking about multiplication and division only. This is multiplication. So 1 times 2 is 2, but the signs are different, so the answer is negative. 4 times 1 is 4, but the signs are the same, so the answer is positive. And so the treasure is at negative 2, positive 4. There is the treasure, and X marks the spot. Comments or questions on how this was done? Ask questions, because if you're not asking a question, that means you understand deeply. And that means that I could ask you to make your own treasure hunt and you'd be able to do it. So if you don't understand, ask a question, get involved. Brianna, and then Justin.
So every time you, like it's like put yourself to the desk, you don't start over?
That's right. That was a great way of saying it. Is you don't start over. You don't keep going back to the beginning after each clue. Each clue goes from its new location. So we went from here to here. Now the next clue, we stay here and go from there. And we ended up over here, and then we go from there to get to here. You do not go back to the beginning, and I did talk about that while you guys were working. I paused and we talked about that. Does that make sense? You don't go back to the beginning. Justin, your question. Same thing you were going to ask? Good. Other questions? Good. Draw a line across your paper. Today, we start chapter 2. Got a lot of high-level ideas that we're going to be exploring in chapter 2. This is where your world goes from just getting some foundation basic skills to actually utilizing them in algebraic ideas. So today we're going to talk about properties and how they impact different operations. Initially, you're probably going to have no idea what I'm talking about, and that's fine. But as we go through today's lesson, you're going to understand more and more about how certain math rules can actually make you work more efficiently. So, properties. We're going to talk about 2 today. We're going to talk about the commutative property of addition and the commutative property of multiplication. They are actually the same thing, except one is in the context of addition and one is in the context of multiplication. Yes, Ethan?
What about the homework?
We're going to get to that at the end. So, the commutative property of addition. It's not commutative, it's commutative. And the only memory device that I can teach you is the word commute. When I go from my home to work, I commute to work. That means I travel. When you go from your home to school, you take a bus, you commute to school. It means you travel. The commutative property of addition says that when you're adding 2 numbers, it doesn't matter which way you add them. The order does not matter. So A plus B and B plus A are going to come out to the same value. 3 plus 5 and 5 plus 3 are going to come out to the same value. There is also the commutative property of multiplication, and it's exactly the same thing, except in a multiplication problem, which is called a product. You can multiply the numbers in any order. So A times B is going to be the same value as B times A. 2 times 6 is the same thing as 6 times 2. It doesn't matter the order. So you need to actually know the word commutative. You need to know the commutative property of addition and the commutative property of multiplication. We are going to use these properties today to help you work through math more efficiently and effectively. The second property that we're going to study is called the associative property. There's two of them. They're the same thing, except one's the associative property of addition and one's the associative property of multiplication. If you are adding 3 or more numbers, how you group them will not change the value. So, if you have 3 numbers, A, B, and C, and you decide to add the first 2 first, and then add on the C, you will get the same value as if you were to add the second 2 numbers and then add on the A. You'll get the same value. This is also true for multiplication. If you're multiplying 3 or more numbers, in this case 3 numbers, if you multiply the first 2 and then get the result and multiply the third one, it's the same thing as if you multiplied the second 2 numbers and then multiplied the first one. Changing the grouping doesn't change the product. The word associative, when I think of it, I think of an associate. An associate is a friend, a colleague. So if A's friend is B, they're associated together, we add them first. But it doesn't matter if A's friends with B or if B's friends with C first, it will come out to the same value. So, we have 4 properties, but really it's one property and then another one. It's really the same thing. And the real power is when we learn how to use both of these at the same time, and that's what we're going to be doing today. So that's our first goal, is to be able to use these properties to work through math problems more efficiently. We have a second goal that's somewhat related and somewhat unrelated, and it's the concept of unit analysis. So, unit analysis. This is a life skill that you need to learn. Some of you may have learned it already in another class. But if you haven't, unit analysis is a method for converting units of measurement. And so I'm going to introduce it today, and we're going to learn how to use it. And this is a concept that you should use math, science, economics, psychology, in all sorts of different careers and things in the future. This is a skill that you should be using every year and getting more and more effective at using. I learned this when I was in high school, and I still use it today. So that's the idea, is that it really has nothing to do with math class. It has to do with being an effective adult. Okay? So, what is unit analysis? Unit analysis is a way of converting units of measurement. For example, if I have miles per hour, but I need to know what the speed is in miles per minute. So this is what I need to know. This is what I have. I can convert it using a conversion factor. And don't worry, you're not going to understand right away. You will later on. But if I look up in the textbook or if I use the computer and look online and find a conversion of hours to minutes, I can then cancel out any units that are on top and on the bottom. So I have hours on the bottom and on top. When you have the same unit of measurement on the top and the bottom, they cancel each other out. And then we're left with miles and minutes. And that's how we get miles per minute. So these two disappear, and this is what's left over. Don't worry, you're going to learn how to do it later on. I'm just introducing the idea. Now, if you are missing anything from this page, I have a printed copy of it. You can get it during classwork time, and you can fill in anything you're missing. But some of you are going way too slowly. Some of you are writing like letters like this. It can't be like that. It's quick writing. This is not an essay. This is not a final draft. This is not something you're submitting to a competition. These are notes. And you have to learn how to move quickly. Okay? If you're missing anything, leave a few lines of space on your paper, and you'll get the printed copy from me later. So we're going to jump right in and get started on example 1. Remember the rules. Examples must be copied. Checkpoints do not need to be copied. Copy down example 1, part A, but do not do it. Do not find the answer. Okay, first of all, before we continue, those of you who did your job and have your calculators out, please turn your calculator over so that the buttons are facing down. You may not use your calculator until later on. You may not, at all. All math must be done, all calculations must be done mentally or by hand. But we're looking for mental math. Now here's the question. This week you rode in a car for 42 miles, rode a bike for 5 miles, and rode a bus for 28 miles. Find the total distance. Can someone tell us what do we need to do? I should see every single hand up. Do you know why? Because this is a 3rd grade question. 3rd grade questions, you're in 7th grade, everyone can do it. Chris, what are we going to do? Add. Very good. Total distance means add. But I do not want you to do it. We're going to write it out, and you're going to learn. So, we're going to add 42 plus 5 plus 28. Today's lesson is not about getting the right answer. It is about getting the right answer, but I'm really much more concerned with the choices you make. And so this 3rd grade question, I'm actually going to spend 5 minutes on for a reason. It's not to waste our time, and it's not to do something silly. It's incredibly important for you to open your mind to what I'm showing you. When I say open your mind, that means don't do things the way you've always done them. Think about what we're doing together, and use your brain to try and understand how you can use this in the future. So, 42 plus 5 plus 28. Here are your choices. You can pick up your calculator, which I said you weren't allowed to do, but you could pick up your calculator and do 42 plus 5 plus 28. That would be really easy. But if you punch one number wrong, Ethan, you get the whole thing wrong. And you would never know it, because your calculator doesn't show you the numbers you punched in. It just shows you the result. So you get the wrong answer and you wouldn't even know. Let me show you on my calculator. My calculator, if I do 42 plus 5, it's showing right here what I'm doing. Plus 28. It's showing what I'm doing. This FCAT calculator, which is the calculator you get to use, does not do that. All it does is it shows you the answer. If you punch one number wrong, you would not know that you got the wrong answer. We do not want to use the calculator unless we have to. If you have to, good, use it. It's a great tool. But don't use it foolishly. And if you were to use it in this case, you would be foolish. You're going to see why in a moment. Here's the second option. Here's what many of you learned in second grade, or I don't know when, but you learned to stack them up. 42 plus 5 plus 28, and then you learn to do this. 2 plus 5 is 7, plus 8 is 15. Put down the 5, carry the 1. That's what you learned. Well, that's actually completely it's lunacy. Because it actually has absolutely nothing to do with understanding math. All it is a set of rules to get you by. If you forget to carry the 1, you get the whole thing wrong. It makes no sense. And carrying a 1, what does that mean? Carry the 1. Do I pick it up and carry it over there? It makes no sense. We're not doing this at all. You are not doing this today at all. Okay? So we're not stacking up the numbers, and we're not using our calculator. So what can we do? Well, you just learned 2 properties. So I'm going to start us off. I could do 42 plus 5. I'm allowed to do that because I already said that if I group the first 2 numbers, that's okay. 42 plus 5. Can I have some volunteers tell us what does that equal? Yasmin? So you were able to do that mentally, right? So you get the result of 47. Now add 28 mentally. Okay, you can do that? Good. Put your arms down. I don't want to know the answer. Some of you could do it, but most of you would have to go, okay, well, 40 plus 20 is 60 plus this, and you'd have to do a whole bunch of things. Now I want you to watch something different. Does anyone see something we could do following the properties that I taught you that would make our lives much easier? Deandra. 42 plus 28. So you know that you're allowed to add the 42 plus the 28. Technically, you are supposed to use the commutative property to move this over here and then group them together. So here's what it's supposed to be. You do not have to write this down, but here's what it's supposed to be. And then you group those 2 together and add those. But we do it mentally, and that's fine. But could someone else, Deandra helped us out, but someone else explain why was Deandra's move a really good one? What about these 2 numbers makes it a nice pair of numbers to work with? Brianna? They're both even. Good, very important. What else? There's something even more than that. Alex? When what's added, it turns into a 10. 42 plus 28 equals 10? Well, I don't know what it equals, but you said something important. Could someone piggyback on what he's saying, China?
They're bigger numbers.
Okay, well, that helps too, but you're missing the simple part. Taylor?
The 8 and the 2.
Yeah, these are very friendly numbers. Alex was right, he just couldn't quite put it into words, and Taylor just helped him out. The 2 and the 8 equals 10. Do we need to write that down? No, you can do that in your brain. 2 plus 8 is 10, and then we know that that's 40, and that's 20. So 40 and 20 is 60, plus 10 is 70. And so what you will see is as your brain gets used to looking at things this way, is you will start seeing things much more efficiently. Adding 70 plus 5 is much easier than adding 47 plus 28. Now, there was a lot of us that could do 47 plus 28, and that's fine. But I think most of you would pick up your calculator first to do it, when this way makes much more sense. And the real point is, and you're not going to do this right now, but if I gave you a list of numbers like this, if I said 12, 18 plus 3 plus 17, 19 plus 24 plus 16 plus 32 plus 18, and I asked you to add those, some of you would pick up your calculator, and that would be unbelievably foolish. Because if you punch one number wrong, you get the whole thing wrong. Instead, if you do what Taylor just pointed out and say, oh, well, that's a 2 and that's an 8, that's 10. There's a 3 and there's a 7, that's 10. Here's a 4 and a 6, there's 10. There's a 2 and an 8, there's another 10. Wow, I just figured out the whole thing in 5 seconds. And there's no chance of making a mistake because I didn't have to use a calculator. So there's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 149. No calculator needed. Now, I'm not saying you could do this right now, but that's what we're leading towards. Okay? Does anyone have any questions on why we did this move and why it was beneficial? Good. So now I'm going to start exploring with you. You're going to start making your own choices. So let's look at an algebra question. What if we evaluate 4xy when x is negative 8 and y is 15? Remember, you may not use a calculator. For xy, it's called an expression. We learned that the first day of school. Evaluating an expression when you're given values, we've been working on that since the first day of school. But do not do the problem. This is what you're writing. 4 times negative 8 times 15. Now, you may not use a calculator, and you may not stack up the numbers, and you may not do anything fancy like that. We're doing mental math. So, can someone do something mentally really quickly? Anyone do something mentally really quickly? India? 15 times 4? What's that? No. I'm sorry. You had a good idea, but that's not what it's equal to. Aaron? Okay, but were you going to say 4 times 15? Because I see 4 times negative 8. I can do that really fast. Nobody can do 4 times negative 8 really fast? 4 times 8? You can't do 4 times 8? Okay, so could someone now raise their hand and say 4 times negative 8? What does that equal? Yasmin? Okay, so that's easy to do mentally. So I could do negative 32 times 15. Give me a thumbs up if you can do that mentally. Yeah, you guys need to think before you put your thumbs up, because no, you can't do that mentally. Or maybe you could, but it would take you a while. So actually, even though 4 times negative 8 is really easy, it leaves us with a bit of an issue. So let's go back to what India suggested, and even though she made a small mistake, she had the right idea. We don't do 4 times negative 8. We take the 15 and commute it over here. And so here's the new problem. 4 times 15 times negative 8. Now you're writing along with me. So 4 times 15 you should be able to do mentally. Aaron did it for us already. What does it come out to? 60. 4 times 15 is 60. For those of you who are having trouble wrapping your mind around that, what's 2 times 15?
30.
30. Now double that. 60. So 60 times negative 8. Well, that's actually really easy. Give me a thumbs up if you already know what 60 times negative 8 is. Make sure you're sure, because I'm going to call on you. Okay, not all of us. Put your thumbs down. So now watch this. What if I took this away? Could you do that? Give me a thumbs up if you can do that mentally. Justin, what does that equal? Justin, stop. Justin, stop.
48.
Okay, that's wonderful. But when I say if you could do it mentally, it doesn't mean do it mentally over the period of 24 hours. I'm saying when I say do something mentally, I mean it should be instant in your mind. So you should, yeah, I'm explaining now. Nobody should have to count on their fingers 6 times 8 because you know your multiplication tables like an expert. So could someone quickly tell us 6 times negative 8? What is that, Dalia? That's negative 48. Now what if there's another 0 there? So what does that equal? Christian? Negative 480. So we can find the answer to this. No calculator was needed. And we had a much greater chance of being accurate than if we punched something wrong in the calculator. So Justin brought up a good point. He doesn't realize it, but I've been saying do these things mentally, and I didn't explain what that meant. So that was a really good point that he made. So let me give you an example. Give me a thumbs up if you can do 2 times 3 mentally. Okay? Put your thumbs down. Because everyone knows instantly that 2 times 3 is 6. Instantly. Right? Did anyone have to go, oh, it's 6. Did anyone have to do that? You just knew instantly that it was 6. Well, guess what? 5 times 10. You should know it instantly. You shouldn't have to go 5, 10, 20, 30. You shouldn't have to do that. It should be instant. So when I say mentally, I am saying you should be able to do these things instantly or within a second or two. I'm not saying go like this. Oh, okay. Mentally, he means in my brain, stack the numbers up and then do the multiplication that way. That's not what I mean. Okay? So let's see who's catching on to these rules and how powerful they are. Checkpoint number 1. Let's see what you come up with. You got 2 questions. You got 3 minutes. You may not use a calculator at all. You may not stack up numbers. You must use the properties that I've taught. Tell me. What have I said? Probably 10 times for each. Yeah. Like, what's the first thing you're supposed to do when you're given values and you've got variables? Yeah, 27. Oh, so that's 10 seconds. Oh, so that's really 14. So we write 14. All right. So, you struggled through it, maybe. Some of you may be starting to understand. But the goal of this is to be mind-opening. Here's the point today. If you walk out my door today and you continue doing these basic calculations the same way you always did, then you completely missed the whole point of today's lesson and you wasted an hour of your life. So don't do that. I'm telling you, you should be altering your thinking. So let's see who's starting to alter their thinking. First of all, let's get the answers, but that's not really the important part. The important part's how. So let's start with part A. We got Brianna and then Kiara. What'd you get?
75.
Okay.
85.
We have a difference of opinion. Taylor.
85.
It does come out to 85. And what about part B? Part B, we got Amaya, Alex, Chris.
4,900 or 4,900?
Okay.
4,900, 4,400.
Okay. Comes out to 4,900. So let's talk about method. First of all, you were evaluating expressions, so you should have known that this meant 2 times x. X is 7. So what is the value of this first term right here? What's its value, Dalia?
No, 14 I meant.
14. Very good. So really this is 14 plus y is 25 plus 46. Now, if you sat there and you said to yourself, Mr. Gallup said I have to do this mentally, so now I have to do 14 plus 25. 14 plus 25. If that's what you did, you were a fool, because that was not my point. Could someone tell us what you could have done to make your life easier? China.
Did the 14 plus the 46?
Yeah, you commute the 46 over here, and you've got 14 plus 46, and then you add on the 25 after that. Because of what Taylor taught us 15 minutes ago. 4 plus 6 is 10. Anytime you can find ones digits that make a 10, that makes your life really easy. So that's 10 plus 40 is 50, and then the 4 plus 6 is another 10. This is really 60 plus 25. So Brianna, even though you did it, you got the wrong answer, I know you did it right. You just thought that that equaled 50, right?
Yeah.
Okay. So, and that was, you're not the only one who made that mistake. I had a bunch of students who made the mistake. So 60 plus 25, of course, we get 85. So you know what? For this group of students, even if you didn't do that, you could still do 14 plus 25 plus 46, and you could still get the right answer. But now watch part B. This means 4 times x squared times y. 4 times. X is 7, so what is x squared? X squared. Ethan.
49.
49 times y is 25. Well, Mr. Gallup's out of his mind. There is no way I can do 4 times 49 times 25. That's crazy. No, I don't. Put your hands. You're crazy. You can't do it. You can't. No, you can't do it. Oh, Taylor, you can do it? What other way? Oh, well, why is that? 20 times 4. What is that? Oh. Now, did you look at the expression? Well, you probably didn't see the expression, but she's like, 4 times 25 is 100. Because it's so simple. If you just take the 25 and move it over and do 4 times 25 times 49, all of a sudden by magic, you get this. And all of a sudden, no calculator is needed. And this example, this one example right here, is exactly what I'm talking about. In this form, it seems like there is absolutely no way you could do it mentally. But once you open your mind and pay attention, you realize, wow, I can actually do that. Does anyone have any questions? Good, so now we're going to add one layer of complexity to it, is if there are variables involved. And so in actuality, it's going to seem like it's something new or strange, but it's actually really the same thing. You're going to, 2 lessons from now, we're going to spend a lot of time on expressions like this. So I just want to point out one detail. We have 3 numbers and a variable. We have a negative 37, we have a negative 53, and a positive 67. And then we have a negative k. My only point for this example is really to explain that you can't add numbers to letters. So you actually have to keep them separate. It's still all one expression, but you cannot add the numbers to the letter. So when we write our answer, it's going to say negative k plus something. Our job is to figure out the second part of it. So we've got these 3 numbers, 1, 2, 3. Remember, we cannot use a calculator, so how can we add those 3 numbers effectively? What would you do? What would you add together? Alex?
Negative 37 and negative 53.
So you think we should do this, so we should commute this over here, and we get the negative 37 plus the negative 53, and then we'll have the negative k and the 67. So what do we get when we do the negative 37 and the negative 53? That's not easy. Aaron? We do not get 90. I don't know. Are you sure?
Yeah.
Yeah, it's negative 90. And while it's not a big deal right now for him to go 90, oh, no, it's negative 90, by next year, you have to know instantly that it's negative 90. You can't correct yourself. Negative 37 and negative 53 is negative 90. So now we have negative 90 plus negative k plus 67. So what are we going to add next? Ethan?
Negative 90 plus 67.
Good. So this needs to be commuted over here. We do it mentally. And so now this is really hard. This is not easy, but you should be able to do it mentally. 90 negatives and 67 positives. What do we get? You think you know, Amaya?
Wait. 70.
No. Najee? China? We have 90 negatives and 67 positives. Chris?
37. What possible?
Tony? Yasmin? Chris? No.
It's negative.
Guys are India? It's negative 23. So we get negative k plus negative 23. I'm not saying that's easy, but you guys have to know that when you have, for example, 12 negatives and 9 positives, there's more negatives than positives. 9 of these are going to cancel out 9 of these, and you're going to have 3 of these left over. This is going way back to the beginning of last chapter, okay? That's okay. You'll remember. It'll start coming back to you. You thought we were done with last chapter and we were never going to see it again. Ethan, you had a comment or?
I know the answer.
So does everyone else. It's already written right there.
No, not the answer.
Okay. Thank you for being so dramatic about it. It was, I know the answer. You're like a performer. That was pretty good. Okay, so what happens if we're multiplying a bunch of numbers and a letter? We're multiplying a bunch of numbers and a letter. Well, it's really the same thing. You actually do not do anything with the letter. You just multiply numbers. You can't do anything with the letter. We weren't given a value for it. So we really just have to multiply the 21, the -3, and the 5. When we write our answer, the x will be there. It's going to say something x. So we just have to find the number that goes in front of it. Now, what would you do first? Because you're not allowed to use your calculator. Amaya?
I would do -3 times 5.
Because that's easy for you mentally, right? So what do you get?
-15.
Good. But here's the problem with that. That's a good approach, but now you've got 21 times -15 times x, and I don't know how to do 21 times -15 mentally. Maybe you could, maybe not. Brianna?
I would do 21 times 5.
21 times 5? Well, I'll be honest with you, that's what I would do. And for those of you who can't see it, let me change it. What if it was 20 times 5? What's 20 times 5? Someone raise their hand and tell us. 20 times 5. Justin? 100. So if you can do 20 times 5, you could do 21 times 5, and what does it come out to? 105. So if you do 21 times 5 times -3 times x, and you do the 21 times 5, you get 105. Times -3 times x. Now some of you are already saying, well, Mr. Gallant, you're out of your mind because 105 times -3, I can't do that. I have to do it like I was taught in 4th grade. I have to do this, Mr. Gallant. But you do not have to, because this is lunacy. This is craziness, because it has nothing to do with math. So now answer this question for me. What if I asked you to do this mentally?
That's easy.
And what if I asked you to do this mentally?
It's 15.
So now someone tell us, what's 105 times 3? Raise your hand. 105 times 3, Deandra? Good. Now one's positive and one's negative, so the answer should be? Good. So now we get -315x. -315, and there's this x here, so we put x. Okay? Comments or questions? Comments, questions? Okay? Good. Let's see how you do on your own. Checkpoint number 2. Simplify each expression. I gave you one difficult one and one kind of moderate level one. So what did we get? 1, 2, 3, 4. We got Aaron, Taylor, China, Ethan.
640. Yeah, 648.
Taylor, what'd you get?
160 times C.
Okay, what'd you get?
648 times C.
648 times C.
The correct answer is 648C. And what about part B? What did we get? Start with India, Brianna, and then Kiara.
500 plus N.
500 plus N. 500 plus N.
N plus 500 or 500 plus N, that's the same thing. Very good. So, part B, the only point really was that you had to commute this over to here to then add it to 212, but that was easy. Part A was a little bit harder, so what order did you do the numbers in? Like, how'd you do it mentally? Yasmin, what'd you do? Negative 12 times. And what'd you get from that? Negative 108, and then you multiply times negative 6. I think that was a good approach. A little hard, but good approach. Brianna, what'd you do?
I multiplied negative 12 times negative 6 into a positive number, 72. And then I multiplied by 9.
Yeah, that's what I ended up doing. I mean, Yasmin's approach is great too because negative 108 times negative 6 actually works out nicely. But I would have had trouble getting the negative 108 unless I knew it off the top of my head. So I ended up doing the negative 12 times the negative 6, and you get 72 times 9, which is not easy, but if you can do 70 times 9, that's not so bad. 70 times 9 is 630, 2 times 9 is 18, and you just add them together. So all I did was break it down into this. Okay? All right, so you guys are doing a great job, and I know it's been a long time. We have one more thing we're going to go over. I'm going to modify the lesson so we're not doing a lot of new stuff. We're going to do one more example, and then we're going to have some time to practice on our own. So, everyone write example 3. I do not want you to copy part A. I want you to read it. And then we're going to do some work together. So, I want to introduce the concept of unit analysis, and then we'll touch on it periodically throughout the year. This was the idea that I said to you was a life skill. So there's going to be a lot of times throughout high school, college, where you need to convert measurements. So I'm starting with a simple example, the Boston Marathon, or any marathon. A marathon is a 26.2 mile race. How long is that in inches? So that's difficult to do, okay? So here's how unit analysis works. Everyone draw a long fraction bar. You should have written part A, of course, and everyone draw a long fraction bar like that. And then equals. And so here's how unit analysis works. You start out with the number you're trying to convert. So we are trying to convert 26.2 miles. It's going to go all the way to the left. 26.2, and you have to put miles. MI is short for miles, so just put MI. Or write miles, either way. That's what we're trying to convert. Now, all the way at the end, we want the units of measurement that we want the answer to be. We want it in inches, so our answer needs to be some number of inches. So I have my starting units of measurement and I have my ending units of measurement. Does anyone have any questions so far? This is how it works. This is what you have to do to use unit analysis. Now, we need conversion factors. What I need is a conversion from miles to inches. And I'm going to put that information right here. I need miles to inches. I want the miles to disappear, so that means that I need miles to be on the bottom. Anytime you have a unit of measurement on top and the same unit on the bottom, they will cancel each other out. That will cancel that. But I have to find the right conversion factor. So what I would like to find is miles to inches. That's what I want. So now I have to find it. So everyone take the textbook from underneath your desk and turn to the very last page. And find me the conversion from miles to inches. Miles to inches, please. Miles to inches. The miles to inches one. Can someone tell us? Kiara.
You mean like the length? Like, is it right here?
I want the conversion from miles to inches. Like I see, it says 1 mile equals 1,760 yards. But I want the one that says 1 mile equals something inches. What's the one that says 1 mile equals something inches? Christian, do you find it?
Oh,
China?
5,280. Wait, you said inches?
Yeah.
Oh.
So what's the one you found?
I found feet.
Okay. So is there one that converts from miles to inches?
No.
Okay. So there is none. And that's true, is you'll never find one. But that's not a big deal. So we can't use miles to inches, but this is the entire purpose of unit analysis. We do know miles to feet. So now everyone write feet right here. And now we have the conversion factor, 1 mile, and so we're going to write a 1 right here, equals exactly what China said, 5,200, that wasn't very good, 5,280 feet. And so I will cancel out the miles, that will cancel that, and when I multiply the top, I'll get feet. But that's not what I want. I don't want feet, I want inches. So now we just need another conversion factor. Because now I need to get rid of the feet, I need another conversion factor right here that will help me get rid of the feet. And so I need feet at the bottom. And then if possible, I would love to have inches on top. Is there a conversion from feet to inches?
Yes.
Aaron?
Yes.
What is it?
1 foot.
So 1 foot is 12 inches. And so I have a second conversion factor. The feet here get canceled with the feet here. And now look. The only unit of measurement left is the inches, which is what I wanted. And now all you have to do is multiply straight across. You multiply the 26.2 times the 5,280 times the 12. Multiply the 1 times the 1, and then divide them at the end. Now, luckily, 1 times 1 is nothing. It's just 1. And I am not asking you to do the top mentally. I told you that we're going to use our calculators for the last concept. So everyone pick up your calculator and now do 26.2 times 5,280 times 12. And how many inches are there in the Boston Marathon? How many inches are there? Don't say it out loud. How many inches are there? We got 3 people who got it. 4 people. 5, 6. We got a bunch of people. Chris and then Dalia. Chris, what'd you get?
63,360.
Okay, and Dalia, what'd you get?
166. You spell it, please. 1660032. That's right.
Okay, so you guys totally disagree, and they're nowhere near each other. Deandra?
What do they say?
What is it? Oh, come on.
I know how to say it.
Someone know how to say it?
Yes.
Someone confidently say it?
Yes.
India?
1,660,032.
That's exactly right. 1,660,032 inches. What'd you do, the first part?
Yeah, I did the
That's okay.
mile to inches.
Okay.
I got the answer right here.
Okay, good. So that's unit analysis. Unit analysis means you just use conversions to get rid of the units you don't want, and then you get left with the units you do want. Okay? I don't expect you to be an expert at this right now. It was an introduction to it. I did have more that we were going to do, but I would rather you have practice time. So, everyone draw a line across their paper. And your classwork is page 66. You're going to do numbers 21, 23, 25, 27, 29, and 33 and 35. So you've got 7 questions, and you've got about 12 minutes or so. Yeah, Chris.
Are we gonna change the mark?
Yeah, we'll see if we have time. And you're going to need the back of the book again for the last couple of questions. And you may not use your calculator for the first 5 questions. You may only use your calculator for the unit analysis questions. If I catch you using your calculator. All right, pick up your colored pens. So let's see how we did. There's a lot wrapped up in today's lesson. Let's see. Number 21, negative 8,100. 23 is 56. You could not use a calculator for either of those. It required some thought and what we did today. Number 25, j minus 6. If you put negative 6 plus j, that's the same thing. Number 27 is 130y. Number 29 is the commutative property of multiplication. So you just had to identify what property. And 33 was 7,500 grams. And 35 was 3 feet. I'm sorry, 3, not 3 feet, 3. It's 3 square feet. Sorry. So number 35 was very difficult. I don't want you to worry about it. If you got it right, you're way ahead. But you should have been able to do number 33. Unfortunately, I am behind schedule. I can answer a quick question or two. Go ahead. Number 27. Okay. So the point of 27 was really the property. The point of 27 was understanding that you had to use the commutative property to commute this over here to do 26 times 5, then times the y. So maybe were you able to understand you had to do that? And then the question is, how do I do 26 times 5? Doing that, we're not done, ladies and gentlemen, I'm sorry. Doing that mentally is not easy, but it's something you need to start getting used to, because you can do this. We did it a little while ago. Can you do 20 times 5? Can you do 20 times 5? What's 20 times 5? Good. Can you do 6 times 5? So what's 100 plus 30? Times y. So 26 times 5 is really 20 times 5, 6 times 5. You can do this with any number in the 20s, right? If you had to do 22 times 8, you can do 20 times 8 plus 2 times 8. Okay? Does that make sense?
Yeah, I messed up specifically with 5 times 6. I put 100 times 6. And that was what I answered.
Oh, okay. I see what you're saying. Okay. All right. Draw a line across your paper. Your homework is in the textbook, same page, 66. You're doing 16 through 46, the even questions only. And you will have a quiz next week. And it will be 2.1 to 2.3, which of course we haven't done yet.